Hello everyone, myself Mr. Untitled Kulkarni, Associate Professor, Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. Today I am going to deliver a video session on basic laws of convection and radiation. In my previous video session, we have discussed about the various modes of heat transfer and Fourier law of conduction. Today we are going to discuss about the laws of convection and radiation. At the end of this session, student will be able to state definitions of convection and radiation and also the state laws of convection and radiation. Contents of this video session are definitions of convection and radiation heat transfer phenomena, Newton's law of cooling, which is the basic law for convection heat transfer, and Stephen Boseman law, which is the basic law for radiation heat transfer. Now, as we experience in our day-to-day life, that there are many processes in which the convection heat transfer process occurs. So what is convection? Convection is the process of heat transfer by the bulk movement of molecules within the fluids such as gases or liquids. So convection will happen only in case of gases and liquids, not in solids, because in solids molecules do not move, they cannot move, leave their places. The initial heat transfer between the object and fluid takes place through the conduction. So for convection heat transfer to occur, we require a solid surface and surrounding fluid. The heat may be transferred from surface to fluid or fluid to surface depending upon the temperature of surface or fluid. So if the temperature of surface is higher, then heat will flow from surface to fluid. If temperature of fluid is higher, the fluid will reject the heat to the surface. So both way it is possible. So initially the heat will be conducted and then there will be the bulk heat transfer which will happen due to the motion of the fluid. Now in convection there are two types of convection. First is called as the natural convection and other is called as forced convection. Let us see what is natural and forced convection. Now in natural convection, the bulk motion of molecules or the motion of molecule occurs due to the buoyant force which is caused by difference in density. So whenever the fluid gets heated, its density will decrease and it will move up and its place will be taken by the molecules of cold fluid, and that is why whenever the motion of molecule occurs because of density difference, which is the result of temperature difference, then this process is called as natural convection. For example, as we experience, the natural convection occurs from electrical conductors on the towers to the surrounding air. The natural convection can also occur in oceanic winds. The heat transfer from the fluid from the fins which are put on the motor bodies or the transformer bodies to the surrounding air. So there are various examples of natural convection. Whereas forced convection is the phenomena when the fluid motion is caused by some external sources. For example, if we use fan, motor, or in case of liquid we can use pump for causing the motion of molecules, and when the fluid is also getting heated, then it is called as a forced convection. The examples of forced convection are when using water heaters or geysers for instant heating of water. So in case of instant water heater, we are passing the water under with certain velocity, so it is called as a forced convection. Suppose when we use a fan on a hot summer day, there the air will be moving, okay, or air movement is caused by the fan. So this is the example of forced convection. Now in convective heat transfer, we are going to define one important term which is called as the heat transfer coefficient, which is defined as the rate of heat transfer between a solid surface and a fluid per unit surface area per unit temperature difference. This definition is derived from Newton's law of convection. H is equal to Q upon delta T, where Q here we are calling as heat flux, that is heat flow rate per unit area. The unit of H is heat transfer coefficient is watt per meter square Kelvin, and delta T is temperature difference between surface and the surrounding fluid in degree Kelvin. Now coming to the basic law of convection, which is called as a Newton's law of cooling. According to Newton's law of cooling, the rate of heat loss from a body is directly proportional to the difference in the temperature of the body and its surrounding. So the equation for Newton's law of cooling is given by Q is equal to HA into Ts minus Ta, where Q is the heat transfer rate in watts, Ts is temperature of the surface, Ta is temperature of surrounding fluid, H is the heat transfer coefficient watt per meter square Kelvin, and A is the surface area. So in convection, the heat will be lost from the surface. Therefore, we consider the surface area of the fluid. Now coming to the radiation, what is radiation? Thermal radiation actually is generated by emission of electromagnetic waves, and these waves carry away the energy from the emitting body. So whenever the body temperature is higher than the absolute zero, these all the bodies will emit the radiation in the form of electromagnetic waves. The radiation can occur through a vacuum or transparent medium, which can be either solid or liquid. The thermal radiation is actually the result of random motion of molecules within the matter. Now there are some characteristics of radiation heat transfer. Radiation refers to the transport of energy through the space in the form of electromagnetic waves, and it depends upon the electromagnetic waves as a means of transfer of energy from a source to receiver. Mechanism of transmission is photon emission. So the body emits photon, and these photons carry the energy. So this mode of energy transfer does not require any medium, means radiation can also occur in the vacuum. The significance of radiation is that it is the only mechanism for heat transfer whenever the vacuum is present, means conduction and convection cannot occur in vacuum, whereas the radiation can occur in vacuum, rather it is dominant in vacuum. Now let us see the examples of heat transfer by radiation. In day-to-day life, we observe that we are receiving the heat from the sun to the earth. So this energy, solar energy which we received in the form of heat, is the example of radiation. Use of energy from the sun in solar water heater. So in solar water heater, we are absorbing the solar energy. So that is again the thermal radiation, thermal energy in the form of electromagnetic waves. Heating of cold room by radiant electric heater. So when you use electric heater, it emits the radiations, and because of which the room will be getting heated. Now coming to some basic terms of radiation: absorptivity, reflectivity and transmittivity. Any substance which receives and emits energy in the form of electromagnetic waves. So when the energy is emitted by a heated body and when it falls on a second body, then the second body will partly absorb it, partly reflect it back, or partly it will be transmitted depending upon the properties of the surface as a receiver. Now let us define this property. So total absorbed energy that appears as the heat in the body, that will be energy balance equation can be written as incident radiation is equal to heat absorbed plus heat transmitted plus heat reflected. Now the proportions of incident energy that is absorbed, reflected and transmitted will depend upon the characteristics of receiver, that is the body which is receiving the energy. Now absorptivity is defined as fraction of incident radiation on a body that is absorbed, and it is denoted by A or alpha. Then reflectivity is fraction of incident radiation that is reflected by the body, and that is denoted by R. Whereas the fraction of incident radiation of the body which is reflected is reflectivity, and the fraction of incident radiation that is transmitted will be called as the transmittivity. So total sum, if we write the energy balance as for a body which is receiving the energy, then total incident radiation energy falling on the body is unity. So sum of all the fractions is unity. Absorptivity, reflectivity plus transmittivity equal to 1. Now let us see some examples which and their properties. For example, for opaque material, the transmittivity is 0. Thermal radiation do not pass through opaque material. Therefore, sum of absorptivity and reflectivity is 1. For perfectly transparent material like say glass, the transmittivity is equal to 1. So absorptivity and radiation is equal, reflectivity is equal to 0, because the glass do not absorb or reflect any radiation. All the radiations will be transferred. For perfectly absorbing surface or a black surface, absorptivity equal to 1. And for a body which is having absorptivity equal to 1 and transmittivity and reflectivity 0, that is the body which absorbs all incident and radiation, is called as the black body. It neither reflect or nor transmit but absorb all the radiations incident on it. So it is treated as ideal radiation receiver. Now for example, lamp black is nearest to the black body because it absorbs 96% of the visible light. And for black body, both absorptivity as well as emissivity are equal to unity. Now let us see the Stephen-Boseman law, basic law of radiation. This law states that the emissive power of the black body is directly proportional to fourth power of its absolute temperature. And when you remove the proportionality sign, we get Eb is equal to sigma T raised to 4, where Eb is emissive power of black body and sigma is Stephen-Boseman constant, which value is 5.67 into 10 to the power minus 8 watt per meter square Kelvin raised to 4. Now from this equation we can think that at what temperature the body will stop radiating energy. So from this equation we can see that at absolute zero temperature, that is 0 Kelvin or minus 273 degrees Celsius, body will stop radiating energy. So radiation heat transfer ceases at absolute zero temperature. These are the references. Thank you.